Well, hello and welcome to the Smells Like Money podcast. Join me, Suzanne Chin Taylor, the DooDoo Diva, as I interview guests who are making an impact on how we manage and operate systems for conveying and treating wastewater. As a veteran of the wastewater, trenchless, and civil infrastructure industry, each week I'll be bringing you industry know-how from industry pros who know how. Join me each week as I speak with representatives of organizations that are utilizing disruptive or new technologies and methods, and executives who are excited to share how to be successful and sustainable in our vital industry. So whether you want to learn about the latest trends in technology, in treatment or trenchless, gain tips on training and retaining great talent, or simply how to be more efficient, productive, or profitable, this podcast is for you. Ready? Let's dive right in. Well, hello, and welcome to this week's episode of the DooDoo Diva Smells Like Money podcast. We are continuing our visit with Stan Heimburger of Heimburger and Company. And today's episode is going to be featuring or focused on peracetic acid and its applications in wastewater treatment. Now, Stan, before we came on the show, you were telling me about this is something, it's not a new technology, it has been adopted. It is being used in some locations across the United States, but it hasn't been widely adopted because of state approvals. And so tell me a little bit about the history of that and that, how it's being used in certain areas that you are aware of, and also why this is something that all states should really be examining as a process to be approved.
Okay, sure.
Big question, I know.
I'd be happy to, and I'll try to keep this as brief as possible.
Okay.
So it is utilized right now, peracetic acid, for effluent disinfection, quite a bit in the Northeast, say in Maryland, New York, and what's that other state? Delaware.
Okay.
And one reason for that is because in those states, there's a higher population base, which those of you out west and other Midwest know. But in addition, there's often a wastewater treatment plant just down the river from where the discharge, or there's a potable water treatment plant just down the river from where the wastewater treatment plant discharges. And so there's more concern than in other locations from chlorination byproducts and their potential pathogenic qualities if you consume them as in your drinking water. And so that's one area why I think you see a preponderance of PAA, peracetic acid, use for disinfection in the Northeast. It's not only the Northeast US as well, it's in some of the larger cities up in Canada as well, such as Toronto area. Then you go over and there's, for whatever reason, and I can't fully explain this, but there's quite a bit of peracetic acid being used for disinfection in Ohio, the state of Ohio. Very recently, there's been quite a bit of, let's say, conversion from chlorine-based disinfection to peracetic acid in the states of Colorado, including a very large facility in the Denver area that's been doing it for the last 3 or 4 years. So I think the trend is gradually working its way to the West, where I'm located. And it's now time for facilities that require more of a attention to the disinfection byproduct aspect of using chlorine to use peracetic acid instead, or at least consider it. There is one in my state where I live in Washington using it now. There's also one just a little bit north of me in Vancouver, British Columbia, that has also been using it for a few years. So there are little pockets here and there, but there can be much more expansion of it, as there is in Europe. It's used quite frequently, with less chlorine by far used for disinfection in Western Europe. Let's say Italy, Germany, France.
Well, does it do a better job than chlorine? Is it like, what are the advantages of it? Is it cost, the amount? Is it the byproducts, the side effects of chlorine that makes this more advantageous to consider?
Well, it's a couple things. One is, as I mentioned, and you just mentioned, the disinfection byproducts, the THMs and the HAAs. And those are just two. There are others that are being discovered all the time by improved methodology that need to be considered for, especially as you reuse water and you go with the one water concept, that we only have a certain amount of water on this planet and we need to reuse it and keep it clean. So that's one important one. Another one is that it is really not, it's a two-step process, not a one-step process for disinfection, because you not only need to meet state and regional limits for pathogen and virus control, and since COVID, the virus part of it is getting more and more intensive. And peracetic acid does just as well on viruses as it does on pathogens for control. But you also need to get your chlorine levels in your effluent down to the level of your permit. So it's a two-step process in that you need to add anti-chlor after the chlorination process, which is a second step, something else you need to worry about, and something else that can fail or get out of line, let's say, out of control. So one step with
it. You don't have to worry with the PAA then?
With peracetic acid, there are no disinfection byproducts of concern.
Okay.
Because peracetic acid is made from hydrogen peroxide and acetic acid. Acetic acid, for those that like pickles, is vinegar.
Okay.
And so hydrogen peroxide decomposes into oxygen and water, both pretty good byproducts, I think. Yes. And acetic acid decomposes into CO2, maybe not quite as good these days, but small amounts of CO2, and some smaller chain organics, which break down into carbon, oxygen, and hydrogen naturally in the waterways.
So it's not harmful to the release waters or the receiving waters when they
correct
they discharge. Okay.
Both the aquaculture, it's not harmful to the aquaculture and to, for instance, people that like to fish and capture fish downstream, or swim. That's those sort of things that humans like.
Right. So as far as, using this in, one of the things that I have in the notes here that you mentioned is that a disinfectant to meet pathogen and virus limits in effluent. This caught my eye, including combined sewer overflow, CSO. Tell me about that.
Well, CSO is not a concern everywhere, but it is a concern in larger cities that have old infrastructure and have it happen, such as in my area, Seattle. Seattle has 5 combined sewer overflow treatment plants, and they try to do it in 4 out of 5 conventionally with first chlorination, but then dechlorination. And with wet weather events that happen that can't be planned, they just happen. That's even more difficult to do than in a wastewater treatment plant where things are more planned in a conventional wastewater treatment plant. So to me, one step is better than two. And at some point, I'm going to convince the CSO facilities near me that that's in fact true.
So we're talking about, we talk about OpEx and CapEx to convert to using something like this. Is there going to be a huge financial burden to make a switch? And
No.
Would it only be at the UV point?
No, well, there are combined sewer overflow plants, as I said, in Seattle that
Right.
use chlorination, dechlorination, but they have one that they've just built. In fact, it may not even be started yet, but that's going to be a ultraviolet, a UV plant, rather than a chemical treatment plant.
Okay.
And there's also application for peracetic acid to make the system work better, save capital for those that are building it, save operating expense for those that already have them, by doing a pre-treatment with peracetic acid ahead of the UV train. And why is that true? Why is that the case? Well, that is the case because bacteria and virus like to hide in amongst solids. And frequently, if there are solids that are around a bacteria or a virus at a UV site, it's not fully treated by the system. In other words, there can be some pathogen or virus that goes through without completely being eliminated. If you have a pretreatment with peracetic acid ahead, it goes after those solid materials and oxidizes them with aggressive chemical oxidation prior to, and it will also go after some virus and pathogens as well. But it's the ones that are hanging out with the solids that you want to go after. But then by the time it gets to the UV system, you can be assured that you're going to be more efficient, and it's not going to require you to change out your bulbs more often and use more electricity than you need to. And of course, now we're talking about the electrical grid with the EV automobiles, et cetera, that we need to conserve electricity as we can.
Right.
So I think it fits into that larger picture, if you will, as well.
Well, now, switching gears here, we talked about the fact that it's not adopted or allowed by all states, but there is a way that if there is a municipality where their state hasn't approved this, that they can, I don't want to say experiment, that's a bad word, but they would like to deploy this to see if it could actually have some benefits. That the way that they can do this, because they're not going to have those restrictions, is to deploy this in the collection system. So how would that work? Would that be at a manhole or a lift station? And then what happens as a result of doing that? One of the things that we always talk about, especially with bioaugmentation, for instance, you're deploying it, or any chemical to control H2S or odor, it's only going to work for a certain distance for the amount of deployment. And then it could be upsetting the actual natural balance. So it's killing the bad things, but it's also getting rid of the things that are good that you want to keep. So
right.
How does this?
Can I go into a 2-minute primer just to
Sure,
kind of
absolutely
fill in a little bit what you just mentioned? When you have your collection system, and everybody knows that you have H2S in your collection system, and why is H2S generated? It's generated from sulfate reducing anaerobic bacteria that live in the bio layers of the sewer pipe. and in the deep in the wet wells, and et cetera. And so that H2S, number one, causes odor issues that come up through the manholes that citizens complain about, right? But number two, it also causes infrastructure failure, where you have, and a lot of facilities still have, cast iron piping. A lot of them do. And a number of them, quite frankly, have replaced and have now plastic, and it's not as much of a concern. But, a lot still do. And so peracetic acid has the ability, like another more expensive treatment, except a simpler approach, to have good durational control. Let's say from point of addition, control anaerobic bacteria 2 or 3 miles down the line from where it's added. Peracetic acid is actually, we're getting a little more detailed maybe than you want to, but I need to explain this. It's an equilibrium mixture that's sold. It has peracetic acid in it. The one I work with has 15, 16% peracetic acid. Excuse me a minute, I thought I had my phone silenced. Okay, I'm sorry. But in addition to peracetic acid, the way that peracetic acid is made is that you take acetic acid, very pure, called glacial acetic acid, and you react it with hydrogen peroxide, H2O2, and that generates peracetic acid. But it's actually sold as an equilibrium mixture that has all three of those chemicals in it. So when you add it in the collection system, let's say, because that's what we're talking about, the peracetic acid will survive and go downstream, while the hydrogen peroxide, which is very effective at oxidizing hydrogen sulfide. So the hydrogen peroxide will oxidize H2S between 1 and 100 feet and 3 miles, whereas the peracetic acid will carry and be a downstream durational control, and in fact go after the bacteria that are generating the H2S, because an anaerobic bacteria, they don't like oxygen, and the peracetic acid is going to give them a dose of oxygen that they don't like, and so they don't survive, and so they quit producing H2S to the extent that they are. And this can be evaluated by trial, measuring at various downstream points of addition what H2S is there, and it is actually cost effective compared to another chemical that's well used for that purpose, called bioxide or calcium nitrate, depending on if you want to use the trade name or not. But that's expensive. You're going to save at least 15 to 20% in operating costs by using peracetic acid. And you don't need to use much of it. You need to use 1 to 3 parts per million peracetic acid in this application.
Wow. So is this something that people could try on a not a performance, but on a pilot or a trial run to see if it would actually be effective in their particular scenario or system?
Absolutely, and I recommend a pilot trial of maybe 3 to 6 months to get a good idea, to get enough good data to evaluate, to give you your answer. But one additional thing, which I also want to mention, is that fats, oils, and greases, called fog, are also oxidized by peracetic acid. and not by any other chemistry that's now used for odor and corrosion control. So you get that added benefit of needing to deploy trucks down there to free the fog plugs that a lot of utilities frequently need to do. It just maintains a low fog level as it works.
Okay.
So some of it is going to do that as well. Added benefit. So
Tell me a bit about, I thought this was interesting too, sludge conditioning for hygiene and odor control. But what caught my eye on this was soil conditioning. Tell me a bit
correct.
about that.
Well, it depends on what location you're at in terms of what happens to your digested cake, or your sludge while it's in storage. But oftentimes, to use your company's name, it smells like DooDoo. And people don't like that smell. So a little bit of peracetic acid can actually treat that and keep that odor from occurring. By the time you anaerobically digest, it no longer usually has that odor. But if you're taking the sludge and then aerobically treating it, which some wastewater plants still are, it can. And in that case, you can denature the final thickened sludge before you take it to a landfill or to agricultural use, which is frequently done instead. And by adding the peracetic acid, it actually oxidizes some materials that are in the sludge at the same time as it controls the odor. And the soil that it goes onto benefits, or the plants that grow in the soil that it is applied to benefit from that addition as well. So both people and plants.
So it almost acts like a fertilizer?
No, it oxidizes some materials that make the phosphorus become available as a nutrient.
Okay. Interesting. Well, Stan, this is for some of you, I know some of this is a little over my head and I'm trying to wrap my head around it, but it's fascinating stuff and absolutely worth exploring further for its potential and its applications. And so for those of you who are interested in getting more information, you can find Stan on LinkedIn and also at his company's website, which is Heimburger and Company, and that's all spelled out. That's HEIMBURGERANDCO.com. And Stan, they can reach you by phone too. If you could please repeat your phone number for us.
Yes, it's area code 360-319-8234.
Well, thank you for sharing your expertise and opening our eyes to some of these new things that we may not have been aware of, or maybe we have, but never have thought about how it could be incorporated and used in treatment collection systems and whatnot. And so for those of you who are listening, thank you for tuning in. And I encourage you to reach out to Stan to explore possibilities, get additional questions answered. He is a wealth of knowledge on chemistry and these subjects. And so thank you for tuning in. And until next time, keep it flowing. Thanks so much for joining me, the DooDoo Diva, on this week's episode of Smells Like Money. What stood out to you this week? Share your takeaways by leaving me a review. You can find out more about the new technologies, creating sustainable solutions, and insights on how to succeed in our vital industry by subscribing to the show. Whether you want to learn about the latest trends in wastewater infrastructure, treatment or trenchless, you've got it all right here at Smells Like Money. If you're an industry expert and would like to be considered as a guest for the show, book a quick chat with me by visiting calendly.com/the2it group/B-A-podcast-guest, or simply click the link in the show notes below. Until next week, a big shout out to all my industry friends and those who will be. You are my superheroes. Thanks for tuning in, keeping it flowing, and we'll see you all next week.